Hello there and welcome to another one-on-one math lesson. And here I and Mr. N, we are working on a new chapter now. I think it's called Maximizing and Minimizing Rectangle. Alright, so rectangles and squares and rectangles, maximizing and minimizing it. Alright, so let's continue with this one. Oh, sorry. You just disappeared. I think you should share screen. You should share like the right screen, the window, not like just that tab. Try again.
Yeah.
You share the wrong screen. That's why it just stopped. Okay. Seeing it now.
Yeah.
All right. Very good. Okay, so first count number of units around edge, there. What's the measurement code? Like discounting, isn't it?
Yeah.
Around the outside edge. Just around, right? Just the perimeter. Perimeter. It's just the perimeter, which means around, surrounding something.
Write an equation for the perimeter of this rectangle. Perimeter.
Equation for perimeter of this rectangle. So just count like how many things you have to count is there?
Yeah. Okay. So here 3, 4, 5, 6, 8.
No, just the perimeter alone, like just the outside. I mean, they ask for the outside only. So you have to find out what kind of equation you can come up.
Wait, hold on. Sorry. Sure. So 3. So there are length to 6 units.
Yes. And how about width?
Width equal to units.
It's 5 units for width, right? So basically, the perimeter is just like just count it, and you see.
Yeah.
There are 2 lengths that look the same, right? And then 2 widths that look the same, right?
Yeah.
So perimeter will be 2 times 2 times length, and then plus 2 times width, isn't it?
Yeah.
So that's the formula. 2 times length, 2 times width. So it will be you combine them together, it's gonna be 2 times open the brackets, length plus width, close the bracket. Like that.
Two units. Yeah. Plain perimeter in words. Perimeter in words. Perimeter. Is two length plus two width.
Mm-hmm. So the perimeter is
Right.
2 length plus 2 width, yeah.
Equal.
Which is, careful, that sentence is not grammatically correct. 2 length plus 2 width is already like the object of a clause. So you have to, comma, which is, and then you have to start a relative clause. You know what I'm talking about? Relative clause?
Yeah.
Okay, which is, yeah, which is what? You write it.
In 22 unit.
Mm-hmm.
Perimeter is the distance around the outside edge of the shape. It can also be pi as the number of linear units needed to go around the outside of the shape. Calculate the perimeter of this shape. All angles are right angle, but the diagram is not drawn to scale. Okay, so calculate the perimeter.
This shape is quite weird, isn't it?
Yeah, it's weird.
So you cannot really just do it the same way that you did before.
Yeah.
So the diagram is not drawn to scale, of course, but all the length or the width, they are drawn to scale in relative to each other, right?
Yeah.
I mean, even though the whole thing is not drawn to scale, like in reality, of course. Wait, let me check these things. I'm checking if these things are the same length. 20.
I think this. So
they are not of the same length. I mean, one is like 17, one is like 19. It's not exactly the same, you know.
yeah.
Maybe let me suggest the answer. Huh. What? They do the same thing?
That's weird.
Ah,
it's
I understand now.
perimeter.
Because if you just combine all the length of one, like, you know, a side, and then combine all the width of one side, and then count all the length of another side and the width of another side, it's like it comes up with the same exact formula. Just try it and you will see.
Okay.
Okay, I need to take a break now. A little bit. Okay, let's continue. Thinking about areas. Oh, so first thing we did perimeter, and now it's the
Perimeter.
area. So the whole area, the whole thing, not just the surrounding, you know.
Yeah.
How much it's needed to cover a shape.
Now let's think about area. Area is the measure of how much is needed to cover a shape. This is often described as the number of square units needed to cover a surface. Giving the definition, what is the area of the above diagram? So, the area is 36 unit
36 units.
square.
Yeah, 36 units square. I think with there without s, because we say meter square, not meters square, you know. So no units. So basically unit without s. So 30 units square. All right. Yeah. What?
Oh wait. Oh
What?
wait.
Oh, okay. You got 6 times 5. It's actually 30, not 36. Okay.
Okay. Action. Rectangle of any size. Perimeter or area. Now we use now to investigate the relationship between the area and the perimeter of the rectangle. This will be manipulating and entering your observation into the table below. It has 4 columns: height, base, perimeter, and area. Okay. What to do? Select the show perimeter and the show area. The radio button to display perimeter and area. Drag point C to adjust the height. Just like you can play around with this.
With that one, you can see the area and the perimeter, it changes. This kind of program is fun to play with. Basically, just to get you an idea how perimeter and area will changes according to. Yeah, you should use that game to start, and then you can fill in the base units and things like that here.
Okay, so I 10 base B. B. Show area category. Area 50. Okay. Seeing the pattern. Let's use the data you compile when looking for rectangles with a perimeter of 30 units. There are many patterns in the chart above. See if you can find them. There's this fixed perimeter. What length, height, base produce more square-like building? Give an example.
What length of height and base produce a more square-like building? Okay, so you have perimeter of 30 units. If you have a square-like building, so all of the length and the width should be the same, isn't it?
Yeah.
So, based on the same formula, since the length and the width are the same, you can assume that length plus width equal to 2 times length, isn't it?
Yeah.
So times 2 again, you will get 4. So basically, perimeter of a square is equal to 4 times length, or 4 times the width now. So now 30 units equal to 4 times length. So you would have length equal to 30 divided by 4, which is 7.5 units, right?
Yeah.
So basically, if you have a length of 7.5 units and a what's it called, width of 7.5 units as well, it produces a more square-like building.
Okay. Yeah.
Let's just take 30 as a parameter of this.
Yeah.
Mm-hmm.
Okay, so 7.5. 4 should be
7.5 units, right?
by 4 is equal to 3. So that's an example. Dimensions are closer in length, produce more square-like building. For example, 8 times 7 or 7 times more square-like than 1 times 4. So it's like something close to like a square.
Yeah, square-like building. Of course, if you have like 7.5, 7.5, it would probably result in a square building, like completely square, you know. But that looks so ugly. That looks really, really ugly though. Don't do that. I mean, because according to architecture, you know, if a building looks square, it looks so ugly. It should look rectangular to be like functional, and it look pleasing for the eyes too.
Is the area of the square-like building bigger or smaller than the buildings that are less square-like? Give an example. So it's like depends on. So is the area of square-like building bigger or smaller than the building that less square-like? So it's like depends on what the shape looks like and how the length and width. Like this like 14.1, 14, and it's just like 1. 14 is the length and the width is like 1. Of course the like perimeter would win because the area is like so small.
Now, is the area of this square-like building bigger or smaller than building that other square-like? It depends, of course. It depends on what you start with. Depends on the width and the length that you start with. Of course, you cannot just say that. And you start the width. So basically, the last question they say maybe 8 times 7. It's like 8 and 7, very similar, very near. So if the width and the length are very near to each other, it produces a more square-like building compared to like, let's say 6 or 9, 5, 11 or something like that. Now, but the way we think is just different compared to their answer. Interesting. Remember, math is not just about getting the right answer, it's about the way you think too. There are different ways to approach a problem. So sometimes you don't get the same thing. Don't worry about it. There are different ways to look at it. There's not just one correct answer. There are several, There's several ways.
Yeah. Several ways. Yeah.
Mm-hmm.
So the longer the rectangle, the smaller the area. What's the optimal shape for a building? Optimal is a word that means best or most efficient.
Tối ưu,
Your design.
optimal, yeah. Optimal means the best or the most efficient, the best possible. You know what's the best possible? According to architecture, if one side is like 1 unit, the other side should be square root of 2, which is 1.4 units. It will produce like the most beautiful kind of shape according to architecture, the best shape or the most efficient shape. So 1 and 1.4, something like that. Because other shape would look really ugly,
Yeah. Rectangle of many size. For result both your investigation, it seemed that a square might be the optimal rectangle with regard to the perimeter and area. But how can you be sure? Investigate is interactive. Immersed 30.
Okay, just play around with that a bit and you see.
Yeah. Okay, so this would height and base would be 7.5 each. Now find the rectangle with the closest area to 60.
Use the applet, little small app.
Yeah.
Find a rectangle with the closest area to 60 meters square. You know, just play around with the app a bit. This whole app thing is to help you like visualize what's the best way and to experiment a bit. There's nothing wrong with experimenting and spend some time playing around with the app. There's nothing wrong with that. Actually, it's a good thing. What do you find? What do you find? Tell me. Increase that base and height. Okay, so it's closest to a square. It has to be like the base and the height must be nearly the same, isn't it?
Yeah.
But then the error is like more than 60 already. You see, so maybe just decrease the base a little bit, like just to 7.8, and increase the height a little bit, just a little bit, like 7.6. Maybe 7.7, let's say. Yeah. This nearest is 60, 60.1 something.
60.1.
Yeah, but it's very, very, very close already. So
the perimeter would be 31, and the area would be 60.1. Yeah. What shape maximize the area for a given perimeter? What shape maximize the area for a given? What shape? Hmm. And what shape maximize the area for the given
Second.
parameter?
Oh, you just stop your share screen now.
Yeah, sorry.
Okay, share again, please.
Can you see it?
Yes, now I can. Now I can. Okay.
I can close it. Screen. What shape? Or given perimeter square. What shape minimize the perimeter for a given area?
Mm-hmm.
Yeah. Square.
Are you sure? Minimize and maximizes. Cannot be the
Shape
same, isn't it?
minimize.
Cannot be the same. Sure about that?
No. I'm just gonna take the gamble.
It's a gamble, of course. And see the suggested answer you can see. A square maximize the area for a given parameter. Very good. A square minimize the parameter for a given area. Wow! So it means that it can be both too.
Yeah, it can be both.
Good. Your logic is improving.
Finding the largest area in the area.
Something wrong?
They would have asked for your advice about building a garden. They want to fence the largest rectangular garden possible,
Mm-hmm.
but they only have 18 meters of fencing.
So that is the perimeter because you fence around like the perimeter, right?
Yeah.
So 18 meter of that is the perimeter fencing. Hypothesize.
What do you think the largest rectangular garden area
will
would
look
look like?
like? Today is not a Monday, so tomorrow, Tuesday, Friday, Tuesday, Thursday, and Friday, we should do science, right?
Yeah.
Okay, great.
Explore brainstorm tool and strategy to use to determine the largest area, considering using a online some ground. Choose a strategy. Try it out to determine the largest rectangular garden area. If you don't like the model, adjust or try another strategy. Where's the largest rectangle? Fencing is solo 1 meter segment and cannot be bent or broken.
You can't bend fences. You can't bend fences, of course. So basically, it's just 1 meter segment. So it means it cannot be bent or broken, which means like you cannot have 1.5 or 1.6 or something like that. It has to be a whole number.
They want to fence the largest rectangular garden possible, but have a limit of
18-meter
18
fencing.
meters of
So
fences.
that is the perimeter.
Yeah. So, 18 meters of fencing investigate. Well, 5 and 4. 5 and 4. It's equal to 18. So, yeah. Garden. Length of meters. Width of 4 meters. Perimeter would be 2L plus 2 equal to 15.
You choose 5 and 4, which is perfect because they are like whole number that looks closest to each other, right?
Yeah.
Very good. Your logic is improving. And then 9 plus 9 is like 18, exactly that number. Very good. Largest rectangular line will look like 5, 4, so it's going to be 20 meters square.
Meters square. It will be square as it will maximize the area while minimizing perimeter. Yes. Yeah. Square like. Now that you have chosen your strategy and you are ready to gather information, remember that the fencing is still in 1 meter segment and
Cannot be
cannot be bent.
broken. So just whole number.
Yeah, whole number.
Mm-hmm.
Find the rectangle with a perimeter of 18 and the largest possible area. So we already have one is 5 meters and 5 meter for the length and 4 meter for the width.
Mm-hmm.
Okay. The next one should be 6, 6 for length, and then 3 for the width, and then next 7. Next should be 7 for the length and
Mm-hmm.
2 for the width. 8, and then there's 1, 8, 1. And 1, so it's yeah. Transform wherever you want to improve your result. Improve your result, check the area term, try something new. Sometimes it is a good idea to try another tool or strategy.
Mm-hmm.
Feel free to model your
Thinking
thinking
on the way. Of course, they ask you to maybe think out of the box. Just think out of the box. And is there any other way? Is there any better way? Suggest suggest the answer to see an example. Uh-huh.
Made a rectangle using dimensions.
Mm-hmm. On geoboard. Yes, and you can just match it. Just try to cut out rectangles like that. Using papers or something like that, and rollers, and you can see which one has the biggest area.
Include explain your solution to the problem to a family member or friend. Does it make sense to them and satisfy all the condition of this scenario? What is the largest rectangular garden possible with limited meters of fencing?
Mm-hmm.
That's the best.
Does it make sense to them and satisfy all the conditions in this scenario? So it's mean, is it feasible? Is it possible? Is it even make sense to satisfy all the conditions of this scenario?
Yeah.
I mean, sometimes it does, because in real life you don't like just sell fences that is broken down or something like that. Odd number. It has to be a whole number, isn't it? That's what they say.
And I think that's it for 5.1.
Mm-hmm.
Move on to 5.2. About other shape. After working through our previous learning activity, we conclude that if we want to build the biggest, cheapest house, its footprint should be square. What certainly is true if our house has to be rectangular. What if we could use other shape like circle? Do you think a circle would create a more optimal footprint than square? Take a guess and explain your answer.
You just find that we have a lot of different building shape, like oval shape, or you have a round shape building. Mm-hmm. The biggest, cheapest house's footprint should be square. The biggest, cheapest house. Wow! But then it doesn't mean it has to be beautiful. It's biggest. It means like area. Cheapest, of course, it cost. But then it doesn't necessarily mean it's beautiful, because square house is so ugly. Really, really, really ugly, I have to say.
But it's cheapest.
Oh dear. Don't aim for cheapest. Aim for quality, because you will regret it later if you build cheapest. For
But
sure.
you can always buy none.
Nah, but if you want, you cannot change the house. Once it's been built, you can just basically destroy it and then build again. But then that would cost money to destroy and to build again too. So why don't you just build it beautiful, like to begin with? That's what I mean.
Okay. Using a circle will create a more optimal footprint than a square. Take a guess and explain your answer. Circle. Circle.
More optimal footprint than a square. Okay, circle looks beautiful, but the problem is there's a lot of space that you don't use, right?
Yeah.
So it means it wastes a lot of space even though it looks beautiful. So you have to decide. Life is not always perfect.
To invest the idea of round buildings, you must be able to determine the area and perimeter of a circle, circumference of a circle. When we talk about the perimeter of a circle, we use a special term, circumference. The circumference is about 3 times the length of the diameter. The about 3 is called pi, represented as. What's this shape called?
Pi.
Pi.
Bro, it's basically pi. Pronounced like pi. 3.1415 something. It's called pi. This is a special number that was found for calculating all the round shape thing like circles, you know. You have to use pi when you calculate things related to circle. It's an infinite number of digits because it's like it doesn't end. Like 3.1415 something like after that. There's a lot of things after that. It doesn't end. It's an infinite number of digits. So basically we just use the value of pi most often used is like 3.14 because it's easy that way. So according to the formula, pi is just a number that you use with circle. So circumference, pi times diameter. And it just basically it turns around. It's basically it turns around like one round. Just turn around like one round and you get to the circumference of that. Or because diameter is like 2 times of a radius, right?
Yeah.
So its circumference also equal to 2 pi r. R radius here. Okay, it may take some time to get used to this new term. I'm sure you'll get used to it.
The formula for the perimeter or circumference of a circle is the following. Circumference equal pi multiplied by diameter, or circumference equal 2 pi multiplied the radius, where d is represent diameter and r represent radius. Area of a circle. Many mathematicians developed many methods to find the formula for the area of a circle.
Lucky for us, the formula for the area circle is well established.
As A area equal
pi r square.
pi r squared.
Just say pi r square. So the radius has to be time itself. So the radius square, and then you times that to 3.14, which is the pi, and you get to the area pi r square.
Explore the relationship between the radius, diameter, circumference, and area of a circle using this interactive. Radius. Change the radius to the unit of circumference is close.
So you know, because it's a circle now. So basically it cannot have any weird shape like different width and height or something like that, yeah? It's just like radius. Otherwise it's not a circle, right?
Yeah.
Know what I mean?
Yeah.
Okay. Alright, so close as possible to 30. Okay.
Yeah, right here. 4.9. Right now.
How about 4.8?
Yeah, 4.8.
Yeah, 4.8 sounds like better. What's the area of the circle to the nearest square unit? It's 72 point nearest square unit, huh?
Yeah, so 72.4.
72.4, I think.
4.
Yeah, 72.4. 3 sig fig, isn't it?
Yeah.
3 significant figure. Okay.
Recall from previous learning activity that the optimal rectangular shape with a perimeter of 30 unit is a square side length of 7.5 unit. Its area is 56.25 units square. So how does a circle with a circumference of 30 units compare to the optimal rectangle? Actually, the circle is over 25 bigger in area than the optimal rectangular shape.
Mm-hmm. So if a circle with circumference of 30 units, you can get to the radius, isn't it? Due to the formula. So from that, you can calculate the area. Just see it. Just try it. You will see it. You will see it. No, just do it. Don't just look at suggested answer for yet. Just try to do it.
Let me mean the circle is the optimal shape for your house. What? So why don't we build a circular house?
Okay, try to set screen again. We have 45 minutes left.
Yeah. Okay, wait. In math. The optimal shape to use. Circular house. Many problems.
I think someone just called me now. No, basically just a woman from the embassy called me. The American embassy in Vietnam, in Ho Chi Minh City, they invited me to a party. Basically, and I'll play piano there on the 6th of July, 6th of June.
That's cool.
Wow,
Cool.
it's really good. Of course, I mean I've been waiting for like forever for these kind of opportunities, so so excited.
Okay, so circular house to cause me problem. You can have space left. Left over space. Between there. Consolidation on the area and the circumference of each. Area. Okay, number one, define the area and circumference of each. So the area for A is 452.39.
Should be easy because you have the formula.
And the circumference is 75.4.
Then check the answer for the for is it correct or not.
Okay, move on to B. Eighteen centimeter.
Where's my sage? Oh, there it is.
B. This should be 14 multiplied by 9 divided by 2 should be 14.13. Circumference. Circumference should be divided by 2 should be 28. 26. So this is just the answer.
You got the same answer?
Yeah.
Okay, good. Alright. This smells wonderful. Sage. Okay, this is half of a circle. So basically at just half of the circumference and then plus that 18, right?
Yeah.
Good. Your logic's improving.
So what is the area of a 100 meters wide pathway around a circular fountain radius of 6 meters? Use so what is the area of a meters wide pathway around a circular fountain with a radius of 6?
Around a circular fountain. So basically, you just have to. What are you gonna do? You're asked to find a green area.
Yeah.
So what's your strategy? Tell me.
So my strategy would be
You're asked to find only the around the fountain, so only the green area. So what would you have to do now to find that area? Be creative.
Yeah, I'm still thinking about it.
Okay, I'm waiting. Don't worry, I'm waiting. I'm a very patient man.
What's the my pathway around those things?
You don't know? Okay, my hint for you now. Okay, so basically take the area of the bigger circle, which is it has a 10-meter radius, isn't it?
Yeah, 10.
Okay, 10-meter radius, you can get to the area of the bigger one out there, and then you find the area of the smaller, the blue circle which is have a radius of 6, and then you take the bigger one minus the smaller circle, you will get to the green area. That's all. Does it make sense?
Yeah.
Okay, try it.
Okay, so
It's funny. I don't think this one's that hard, but maybe okay, sometimes hard.
area radius. So 14. So I think it should be 615.44. No,
Show suggested answer. Show suggested answer.
nearest 100 is 16. The area of the pathway would be the difference between the area of the inner and outer circle. Oh.
You got the same answer?
Oh, I got it wrong.
Ooh.
Yeah, because I was like, anyway. Yeah, because I was like calculating all of this together and not like yes. Okay. Calculate the area of the shaded region. Express your answer to the nearest 10 centimeter. Shaded region. 10.6. Okay, so calculator. This So the total area should be 103.4 centimeters squared for this.
Check your answer carefully again, please.
So the answer for the whole area is 103.4 centimeters squared.
Could be. Check it out. No, it's different. 113 point something too. Okay, check again. Check again the answer. Alright, rectangle is 60, yes.
No, I got it right, but I just said the wrong.
Oh, that's right.
I just said the wrong.
Sorry, I'm just being too sarcastic.
It's 103, not 113.
Okay. You said it.
Anyway. Find the distance around the area of the overall running track. Around the outside of the overall running track. This I think for number four. Wait, what? So for number four, the answer is 388.4 meters squared. So this one is like
Yes.
so this one is like the answer for this one is 388.4 meters squared.
You sure about that?
Yeah, I'm sure. Yeah, it's 388.4. This thing
Okay,
right
great. What's the unit?
It's meter.
Of course, because it's the perimeter around.
Yeah. And that's it to like two. Let's move on. Right angles. In the last learning activity, you calculate dimension, building, and learn that most holes building are rectangular. Did you wonder how the carpenter managed to build them in perfect rectangles? Constructing a perfect rectangle is more difficult than most people think.
almost forgot to apply my cream or Vaseline. I'm inside the air condition room all the time, so need to be careful with humidity. Don't want my skin to look like a 70-year-old lady, you know. Oh man. Making a rectangle. Polygon tool, make a rectangle. Click on 3-point to measure an angle. Measure all four angles. Okay, so right angle means like 90 degree.
Yeah, 90 degrees.
Okay. God, this Vaseline smells exactly like cacao, like chocolate.
Okay, so are all corners all 90 degrees? No. Some are different. The difference between making a rectangle and constructing a rectangle is important. To construct a rectangle, you need to be certain that measurements are correct right from the start. What would you do if you had to make a square corner and didn't have decimal handy to check? For that matters, how did people make square corner in the days before computers? The answer is that they use a mathematical strategy called the 3-4-5 triangle. It is based upon an amazingly useful theorem worked out by an ancient Greek mathematician called Pythagoras. He used the Pythagorean theorem in Unit 2. When you are in your equation solving skill, in this learning activity we will explore some application, its famous formula. Action. Ever wonder how a farmer can square the corner post when constructing a rectangular paster? Or how a conductor laying out the foundation of his house square a corner? To square means to make a 90-degree turn. When you're building a fence that might be hundreds of meters long, squaring off that corner correctly is pretty important. Otherwise, the fence would end up on someone else's land.
You don't want your fence to end up on someone else's land because that is an invasion. And then they will sue you if you do it wrong. You know, they will bring you to court if you put your fences wrong. You know. Or well, even though if your relationship with your neighbor is good, but still, if you do it wrong, they will get very angry and the relationship will turn sour very quickly. And then they will sue you. It's like that. So, squaring out the corner correctly, it's pretty important, you know?
Yeah. Even internet search for squaring fence.
What did you discover? Note your reflection in learning log.
Squaring,
Skinny day.
verifying that an angle is 90 degrees. Can you verify that this jar layout is square? Measure
What?
3 long.
This year layout square.
Yeah.
So you need to figure out if that angle is right angle or not, 90 degree or not. So if one is like 3, another 4, and another is 5. So it followed the Pythagorean theorem perfectly. Oh, we okay, you know what Pythagorean theorem is, right?
Yeah.
Okay, so hypotenuse square equal to one side square plus another side square, right?
So it's like a squared plus b squared equals c squared.
Yes, hypotenuse square equal to one side square plus another side square. So 5 square, so basically 5 square, how can I write it? Power of 2 equal to 4 to the power of 2 plus 3 to the power of 2. There you go. So 543 is actually perfect numbers, you know.
Long ago, fiddler are often craft 3-4-5 rope, not cord, to save time. A rope 12 unit long is marked with not as 3 and 7 unit point, thus dividing it into section 3-4-5 unit long. This simple tool has been discovered in archaeological digs and has been around for a very long time in various forms. Hypotenuse. For the rest of the learning activity, we will focus on the famous
Pythagorean theorem.
Pythagorean theorem.
Pythagorean. I think it's Pythagore because he is Greek, so his name must be Latinic. Pythagore. So basically, it just appeared. I mean, that way you pronounce it that way. So Pythagorean theorem. The legs and the hypotenuse.
Most students remember the
Pythagorean. Just say Pythagorean theorem. That's what I do. It's all about right angle triangle and the length of the side, but this isn't exactly correct.
The length of the side, but that isn't exactly correct. The Petagorian theorem is really about the area of square
attached to sides.
It's like square attached to each other.
Pythagorean theorem. I think it's maybe this one you should spend time to watch about it.
Yeah.
And is there more about Pythagorean theorem? Maybe we should do it next time, maybe.
Yeah, next time.
I think so too. Alright, so I'll see you then. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh á, để mà các bạn có thể được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.